Hello, students. Welcome to video lesson 8-2. In this video, we're going to be talking about special right triangles. Okay, so right triangles where we don't actually need to use the Pythagorean theorem to find missing side lengths because we have other rules and other ways to do it. If we know even just one side length, we can find the other two using these rules. Okay, but it is sort of based on the idea of the Pythagorean theorem. So if we take this particular example here, where we're looking for the hypotenuse length of this right triangle, one thing I want you to notice is that these two sides are 100% the same. The two legs are congruent to each other. So, you know, this and this, they're the same. That makes this triangle isosceles. Okay, so this is an isosceles right triangle, and we'll talk more about what that means in terms of angle measures in just a second. But if I'm going to use the Pythagorean theorem to find this value x, because that's the hypotenuse, I know that's going to be my c value in my Pythagorean theorem. And a and b in this case are both 3, right? Because it doesn't matter which of those I use in which spot, they're both 3. And if I solve or start to do the arithmetic here, 3 squared is 9, plus 3 squared is 9 again, is equal to x squared. So 9 plus 9, well, that's 18, right, is equal to x squared. So if I unsquare those, I don't think we know the square root of 18. And I did tell you in the last video that we can just decimal approximate everything. I'm not going to do that here because the rules that we use are actually going to write things in simple radical form. So I'm going to take the 18 and I'm going to split it up. Okay, I'm going to think what perfect square number divides into 18. Well, that would be 9 divides in there twice, right? So I can square root each of those. And what I end up with is 3 radical 2 is equal to x. Okay, so this value right here is actually 3 radical 2. And that is going to happen all the time. What I mean by that is the hypotenuse length in an isosceles right triangle where the two legs are the same. If the two legs are the same, the hypotenuse length will always be the length of the leg multiplied by the square root of 2. Okay, all the time, every time, no matter what. So if, for example, I have a right triangle like this, and I know that both of these lengths are 5, right, that's a right triangle, then the hypotenuse length here across from that 90-degree angle must be 5 radical 2, okay? So if we look at what our book does, they have a theorem about this. They call it the 45-45-90 triangle theorem. So a 45-45-90 triangle is a triangle that has two 45-degree angles and a 90-degree angle. That's another way of saying isosceles right triangle, because remember, in an isosceles triangle, if these two side lengths are equal, then the angles across from them are equal, okay? And if we know that the angles are equal, we can do some math and find that they're 45 degrees, okay? So 45-45-90 triangle is the same as saying a right triangle with congruent legs. Okay? The two sides that meet at the 90-degree angle are congruent to each other. If we have one of those triangles, then the hypotenuse length is just the side length, or excuse me, the leg length times the square root of 2. Hypotenuse is equal to the leg times the square root of 2. And that's how we will write it in simple radical form. There's no square rooting to be done. We don't have to split anything up or anything like that. So when we have a 45-45-90 triangle, I do expect to see your answer with the radical in there, okay, with the radical 2. So, you know, we looked at an example just like this a second ago. Here we're given a 45-45-90 triangle and we're told the length of this leg is 9. That means that h, the hypotenuse length, must be 9 radical 2. Okay? Now over here, notice that my leg length this time says 2 radical 2. So 2 radical 2 already has that radical 2 on it, but to get to the hypotenuse, I need to multiply or times again by radical 2. So my hypotenuse actually ends up being 2 radical 2 times another radical 2. And if we remember our rules about square rooting, the square root of 2 times the square root of 2 is really the square root of 4. So this is really 2 times the square root of 4, right? But 2 times the square root of 4, well, the square root of 4 is just 2, right? So that's 2 times 2. It ends up being 4. X is equal to 4. So when you have a leg length that already has the radical 2 in it, you'll multiply again, and it'll become the square root of 4, which is just 2. And so it will basically always double this number, okay? It'll double that number. Just as one more example, if you were to see a right triangle where both of the legs, I'll mark these as congruent. That shows me it's 45, 45, 90. And if I know that this is, let's say, 3 radical 2, when I multiply it by radical 2 again to get the hypotenuse, it's just going to end up doubling this number, and so the hypotenuse will be 6, okay? So if you know the leg and it has the radical 2, when you go to the hypotenuse, it's basically going to take that radical 2 and use it to double the number in front. Okay, but you can always just go ahead and do 3 radical 2 times another radical 2, which becomes 3 times radical 4. 2 times 2 is 4. The square root of 4 is 2. 3 times 2 is 6. Okay? If we have the length of the hypotenuse in a 45, 45, 90 triangle, and we are asked to find the length of a leg, that's essentially asking the same question but backwards, right? So instead of taking this leg value and multiplying by radical 2, we're going to take the hypotenuse value and we're going to go backwards and we're going to divide by radical 2. Okay, divide by radical 2. Now, that's going to bring back something that we talked about in Algebra 1 that we're going to have to talk about here as well, something called rationalizing the denominator, okay? Because if my hypotenuse length does not have a radical 2 on it, when I go ahead and I divide the hypotenuse by the square root of 2, 6 over the square root of 2, well, I mean, this is a fraction. I'm not allowed to divide the 6 by the 2 because the 2 has a square root, right, on it. So I can't do that. Really, I can't do anything except that I really don't like having square roots on the bottom of a fraction, right? We do not like square roots on the bottom of a fraction because we can make life simpler if we get rid of that square root on the bottom. So what I'm going to do is I'm going to multiply the bottom of the fraction by radical 2. I'm also going to multiply the top of the fraction by radical 2. And I'm going to simplify each of those. So it's 6 times radical 2 over, and then radical 2 times radical 2, that becomes radical 4. Radical 4, though, is just 2, right? Square root of 4 is 2. So I end up with this, right, where the bottom, the square root goes away, but that square root of 2 shows up on the top. Now, the reason that I did that, and the reason we want to do that, is because now I can simplify the fraction part. I have 6 that's not under a square root, and I have 2 that's not under a square root. Can that be simplified? Can those two numbers both be divided by something? Yes, they can both be divided by 2. So the 2 will become a 1, and the 6 will become a 3, and so I get 3 radical 2 over 1. Well, the over 1 doesn't really matter here, so 3 radical 2 is going to be my answer. So I would choose letter B, 3 radical 2. Okay, so when we go backwards and find the length of a leg in a 45, 45, 90 triangle, we have to divide by radical 2, and that usually means rationalizing the denominator, okay, by multiplying top and bottom by that radical 2 again and seeing what we get. Now, if we happen to have an example where the hypotenuse length is given, and this is 45, this is 45. If we have the hypotenuse length given, let's say it's 7 radical 2. When I go backwards to find the leg, and I divide by radical 2, well, what happens when I do 7 radical 2 divided by radical 2? Well, the radical 2's just cancel each other out, right? And the answer would be 7. X would equal 7. So if the hypotenuse already has the radical 2 on it, then it becomes a much simpler process because when I divide by radical 2, it just cancels out, okay? So using this idea of multiplying or dividing by radical 2, we can find the length of any side length in a 45, 45, 90 triangle. Okay, there's another type of special right triangle as well, which is called a 30, 60, 90 triangle. And so that's a triangle where we have a 30-degree angle, a 60-degree angle, and a 90-degree angle. Those triangles also have special relationships between the sides, but the sides are not going to be congruent, right? None of the legs are the same. So we have, different formulas or different rules we can use for each of the sides. Everything here is based on the length of the shortest side of the triangle, okay? And that is always the side across from the 30-degree angle. Because remember, when we have a 30-degree angle, the shortest side of a triangle is across always from the smallest angle, okay? Shortest side, smallest angle. Shortest side goes across from the smallest angle, okay? So if we know the side length across from the 30-degree angle, meaning the shortest side, the shortest leg or the shorter leg, if we want to find the hypotenuse, it's as simple as just doubling it, okay? So we just double it to find the hypotenuse. Take that short side length and double it, and that's the hypotenuse length all the time, every time, okay? In terms of the longer leg, the third side, the other one that meets at this 90-degree angle, we take that shorter side and we just put a radical 3 on it. Okay, we multiply by radical 3. It's important to recognize that when we have a 30, 60, 90 triangle, our radical number is a 3, not a 2 like the 45, 45, 90, okay? So I remember this, you guys, by just thinking 1, 2, radical 3. Okay, because obviously the shortest leg is just 1 times itself, right? 1 times s. Then the hypotenuse is 2 times s, and then the other leg is radical 3 times s. So I think 1, 2, radical 3, just as a way to remember how these side lengths are related. So, for example, if I have this particular triangle right here, this one is probably the most complicated version that we could see, all right? And I'll show you a couple examples in a minute of different pieces of information you could be given, and then you'll see why it's maybe easier to find the others. But in this case, notice the side length that they tell me is 5 is not the shortest side length, right? Because across from my 30-degree angle is actually this variable d. So I know the longer leg, right? The longer of the two legs. I don't even know the hypotenuse length. I know the longer leg. So remember that this was the one that was multiplied by radical 3. So if I want to find the value of the shorter leg, I need to take this longer leg and I need to unmultiply by the square root of 3. Okay, I need to divide by the square root of 3. So what I can do is I can take the 5 and I can divide it by radical 3. Okay, divide it by radical 3. Now, again, this is just like what we saw in the last example. I need to get rid of the square root of 3 on the bottom, so I'll multiply by radical 3, multiply by radical 3. It shows up on the top with the 5, radical 3, and then the bottom is now just a 3. Is there anything I can do to simplify this? 5 over 3, 5/3? No, not really. So this is the value of, or the length of that shortest leg. This is the length of d in simplest radical form. Okay, so now that I know that, what can I do with this value to then get to the hypotenuse? Well, I'm supposed to take the shorter leg and multiply it by 2, right? Take the shorter leg, multiply it by 2. So what I should do is I should just multiply this by 2. It's important to remember that when we multiply a fraction by a whole number, we just multiply the numerators, right? Because this is sort of like multiplying by 2 over 1, so the bottom is not going to change. So this side length here is still going to have a denominator of 3. The top now, instead of being 5 radical 3, if I double it, it's just going to be 10 radical 3. Okay? So 10 radical 3 is f. This is d. This is f. 10 radical 3 over 3. So like I said, these are obviously the most complicated looking answers that we could get when we're asked to find the length of the sides of a 30, 60, 90 triangle, okay? Another example that we could see if I have a 30, 60, 90 triangle here, and the easiest example, the best way, is if we know the length of the short leg, right? Across from the 30-degree angle, I know that this value is, let's say, 8. Okay, this is 8. The length of that side there is 8. Using that information, I can find the length of this side and the length of that side, because my rule from 30, 60, 90 triangles, right, which we all wrote down, is all based on this short leg. So to find the hypotenuse, which would be my x variable, to find that, I'm supposed to take the short leg and multiply it by 2. So 8 gets multiplied by 2, and x is going to equal 16. 8 times 2 is 16. Okay? Then I go back to the shorter leg, and I think, okay, to get from the short leg to the long leg, I'm supposed to multiply it by the radical 3, right? By the square root of 3. 1 to square root of 3. So when I multiply a number that's not a square root by a square root number, it really just shows up like this, right? 8 times radical 3. So y, in this case, this side length is equal to 8 times radical 3. So the short leg gets doubled for the hypotenuse and gets the radical 3 multiplied on for the longer leg. Now that's only slightly more complicated, that example, than if we knew the hypotenuse length to begin with. Right, so if I don't know the short leg, but I do know the hypotenuse length, let's say the hypotenuse length is 20. And this is my x. Now, this is the hypotenuse. I know that the hypotenuse is twice as much as the short leg, right? So the shorter leg is my variable x. This is the short leg. So to get from the hypotenuse to the shorter leg, I should, well, undouble it, right? Unmultiply it by 2, which means divide it by 2 or cut it in half. So my x value is going to be 10, right? Because if I knew the short leg was 10 and I doubled it for the hypotenuse, it'd be 20. So the short leg is always half of the hypotenuse. So if I know the hypotenuse, I can just cut it in half. That's the short leg. Now that I know the short leg, I can then get to my longer leg by multiplying by the square root of 3. So this becomes 10 radical 3. It's the shorter leg's length multiplied by the square root of 3. Okay? So that's basically what your homework is going to be about. Finding the side lengths in these special right triangles. Okay? 45, 45, 90 or 30, 60, 90 using our rules. If you have any questions, do please reach out to me. Let me know. I'll be happy to help. Otherwise, that's all I have for you right now, and we'll talk to you soon.